Hey guys, this is Coach Brian. I'm going to combine the last 2 pages of our review into one final video. In this video, I'll be covering questions 19 through 22. Let's jump right in with 19, which deals with polar coordinates. So, important thing to remember about polar coordinates is you do have an ordered pair, but in your ordered pair, you have r and theta. Okay, so you have a radius, or kind of like which radius are you on, 1, 2, 3, etc. And then you have an angle, theta, and it's going to tell you, at what angle are you either going out towards this angle or going away from it. So my suggestion for these is usually to find your angle first, and then if it's a positive r, you're going to go out from the center. You're going to go out towards that angle. And if it's negative, you're going to go away from that angle. So I'll explain what I mean as I work these. For A, we are going to 3 pi over 2. So again, if you're unsure about your radians or not super confident with them, you can always start at 0, okay? And then you can go directly across from it, and that's always pi. Now, when you start dealing with different denominators, like this one has a 2, this one has a 4, this one has a 6, etc., you can make that pi match whatever your denominator is. 2 over 2 is still 1 pi. 6 over 6 is still pi. And so now halfway is just going to be pi over 2, and 1 plus a half is going to be 3 pi over 2. So that's the angle we're looking at right there, 3 pi over 2. That's the angle for A. Now, 2 is positive. So what that means is we're going to start at the center, and we're going to go out towards that angle, and we're going to go out to the second ring. So from the center, we would go out 1, 2. We'd mark that, and that is A. Now for B, it is a negative angle. And there's kind of 2 ways we can approach this. We can, since it's negative, we could go clockwise, okay? We could do that. That's one option. Or we could take the negative angle and we could add a positive turn to it. We could add 1 full positive turn to it. And when you add a turn, that means you add 2 pi. But again, to add fractions, you have to have a common denominator. So 2 pi and 8 pi over 4, they're the same thing. They have the same value. All I'm doing is adding a turn to it. That gives me 5 pi over 4. And regardless of if I go clockwise or counterclockwise, I end up over here, 5 pi over 4. Okay, 5 pi over 4. And I'll rewrite it also as negative 3 pi over 4. They're the same. They are coterminal, if you remember that from our unit on the unit circle. Now, this r value is negative. So instead of, finding this line and going out to, I'm not going to go out to, I'm going to actually go away from it by 1, 2. I'm going to go away from it since my r value is negative. So for C, negative pi over 6, same thing. I could just go right here because that's negative pi over 6. Or I could add 12 pi to it, which would give me 11 pi over 6. Regardless, I end up there, and it's a positive 1, so I go out to the first circle and mark my point. For D, I'm at 7 pi over 6. So if I start over here at 0, and then let's say I make this 6 pi over 6. It's still pi. I go 1 more sixth, and I'm over here at 7 pi over 6. So that's my angle. And then I have a positive 3, which means I'm going to go out. I'm going to go out towards it. 1, 2, 3. That's point D. Lastly, for E, I've got 7 pi over 4. So again, I could come over here and I could take my pi and I could make it 4 over 4. And now when I'm looking for 7 pi, here's 5. I've already got it marked. This is 6 pi over 4. 7 pi over 4 is right here. 7 pi over 4. And then I've got a negative 3, which means instead of going out towards it, I'm going to back away from it. 1, 2, 3 rings out. And there are my polar coordinates for question number 19. For question number 20, it says the graph of theta equals 2 pi over 3 is well, this is still dealing with polar coordinates. So we have an r and we have a theta. Sorry, I cannot write. We have an r and we have a theta. So what this is saying is if r is, any of the radii, but the angle is 2 pi over 3, what would that look like? So again, I could go to my unit circle. I'd start at 0. I'd go over here at 3 pi over 3. This would be 1.5 pi over 3. So if I'm looking for 2 pi over 3, it is right here. This is the line right here, 2 pi over 3. And if I graphed that, it is a straight line. And if you wanted some points off of it, there are a lot of them. You've got 1, 2 pi over 3. You've got 2, 2 pi over 3. And you could go on to 3, but also not even that. You could go to -1, -2, -3. There are infinite possibilities. Now, pick your favorite. I'm going to go with 1, 2 pi over 3. It just says any point, 1 point, pick any one that you like. This theta just has to be 2 pi over 3. All right, for question 21, it says find the features of the ellipse and graph. So again, this is similar to when we worked earlier. We need to start by looking for the biggest number here. Now, 25 is bigger than 16, which means that is our a squared, and 16 is our b squared. Now, there's a lot more information packed in here. See how the biggest number, 25, is with the x? That means this is a wide ellipse. It's going to look like this. Okay, it's a wide ellipse. Now, x minus h is right there. Y minus k is right there. I need to get the center here. So if it's x minus h and it's x minus 2, that means h equals 2. Okay, these right here, they're the same. But if I have y minus k and it somehow turned into y plus 5, that means k is actually -5 because it would be y minus a negative. That's how you get the positive. So hk is my center. A is going to be 5 because a squared is 25. B is going to be 4 because b squared is 16. And then c is going to equal the square root of 25 minus 16, which is just the square root of 9, which is 3. So I've got all my information here. I'm ready to graph. I'm going to start by graphing my center at hk. It's at 2, -5. Then, since I know this is a wide parabola, like this, since I know it's wide, I'm going to go to the right, 1, 2, 3, 4, 5, and I'm going to go to the left, 1, 2, 3, 4, 5. I got that from my a value. Next, while I'm on this major axis, I can go ahead and plot C, which was 3. So I'm going to count out 1, 2, 3, and I'm going to count left 1, 2, 3. Those are my foci, my focal points. Now, for the B value, B value will be on the minor axis. The minor axis is going to go this way, okay? It's going to go this way. And I'm going to count up and down by my B value, which is 4. So I'm going to count up 1, 2, 3, 4. And I'm going to count down 1, 2, 3, 4. And then once I have all of those plots pointed, I can connect them with a smooth curve, or at least your best attempt at a smooth curve. Mine is never great. All right, best attempt at a smooth curve to create the ellipse. This one's going to be kind of eyeball shaped, if you will. It'll be kind of eyeball shaped. And make sure I counted everything right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Looks good. Now we just need to put the coordinates of the center, the vertices, the co-vertices, and the foci. So for the center, there's just one center. It's at HK, which is at 2, -5. There are two focal points. The first one is at -1, -5, and the second one is at 5, -5. There are two vertices. They are at the ends of the major axis. The first one is at -3, -5, and the second is at 7, -5. Co-vertices, there are two. They are at the ends of the minor axis. The first one is at 2, -1, and the other one is at 2, -9. So there's our ellipse, and there are all of the coordinates of the major points on it. And lastly, taught this one directly in class, vectors. It says you and your friends left school and walked 8 kilometers west. So if we're graphing this, if we start at school right here and we walk 8 kilometers west, okay, we're going to go over this direction. Let me bump this up a little. Maybe. There we go. We go 8 kilometers west. And then it says you turn and you go 6 kilometers south. And now you're at a park after you've gone 8 kilometers west and 6 kilometers south. You're now at the park. Now, those are what we would call the components of this situation. We have our X value and we have our Y value. Now, if you could go from school straight to the park and you wanted to take the fastest way, you would just make a straight line path over there. You would take what we're going to call this vector. Okay? Now, some characteristics about this vector. This arrow has a length and it also has a direction. So we would say that it has two things. It has a magnitude and it has a direction. It has a magnitude and a direction. And those are the two things we want to find out about it. So part one of this question says, what's the vector in component form representing your movement? The components of a vector, to find the components, you would find the change in your x's, which is just going to be x2 minus x1, and the change in your y's. Now, for x2 and y2, those are going to come from the point where we ended up. So if we look at our graph, we ended up over here at -8, -6. x1 and y1 are going to come from where we started, which is 0, 0. So the math on this part is going to actually be pretty easy since we're dealing with zeros. We're going to take our second x, which is -8, and we're going to take away nothing. And we're going to take our second y, which is negative 6, and we're going to subtract nothing. So what that leaves us with in component form is negative 8, negative 6. And if you think about components, just think that's like the parts and pieces. This is your x part of your movement, and this is your y part of your movement. And lastly, again, we want to know the magnitude and direction of this vector. So essentially what we're trying to figure out is if you could start at the school and you could take this straight line path to the park, what's the distance, also known as the magnitude, what's the value, and what's the direction. So we want to know what angle this is. Now, magnitude's kind of easy. We have a right triangle, and it has two sides, negative 8 and negative 6. So we need to find the hypotenuse. Finding the hypotenuse of a right triangle just involves using the Pythagorean theorem. And if you're solving for c, you would find the square root of a squared plus b squared. Now in this case, a squared, we'll use our x, is negative 8 squared. And for b squared, we'll use our negative 6. Now, the place where some people mess up, when you are squaring a negative, it should become positive. It should become positive because a negative times itself, a negative times a negative, yields a positive. So what we're looking for here is the square root of 100, which could be plus or minus 10, but displacement, which is what we're finding here, is always positive. So c is going to equal 10. That is the magnitude of this arrow. And if you go up to the top, all of these distances are measured in kilometers. So we would say that the magnitude is 10 kilometers. Now, lastly, we need to find the direction, which means we need to find the angle, but we need to start from standard position, 0 degrees. So we're actually looking for this entire angle, okay? Now, for this particular setup, you know this whole part of the angle. This whole part of the angle is 180 degrees. What we need to know after this is we need to know what's this last little wedge? What's this last little piece of the angle right here? What is this angle? Because if I can find this part, I can add it to 180, and then that will give me the total angle. So if you look at what we've got here, we've got, from this angle, we've got the opposite and we've got the adjacent. The opposite and the adjacent. And we are looking for an unknown angle. So a lot of information right there. First, if you remember SOHCAHTOA, our trig identities, the one that involves opposite and adjacent is tangent. So we could actually say that the tangent of this angle that we don't know equals the opposite, which is negative 6, over the adjacent, which is negative 8. Now, we are in quadrant 3, where in quadrant 3, all students take calculus. In quadrant 3, tangent and cotangent are always positive. So if we go look, we have a negative divided by a negative, which should give us a positive. So now we're at this point where we've got tangent of theta equals 6 over 8. And that's great, but we still need to know the angle, theta. So what we need to do is we need to find the inverse function of both sides. So we would find the inverse tangent. Those would cancel out, and it would just leave us theta. But then we'd also find the inverse tangent of the ratio. We have to do what we do to one side, we have to do to both sides. And the tangent inverse, which you can put into your calculator, make sure you are in the correct mode, okay, degrees, degree mode. When you put that into your calculator, you should get 36.87 degrees. So that means this little wedge right here, this little wedge is 36.87 degrees. And so what we can do is we can take 180 and we can add the 36.87, and that gives us 216.87 degrees. That is our direction, 216.87 degrees. So we were able to calculate the value of the vector, the arrow, as well as the very, very exact direction of that arrow, going 216.87 degrees. I mean, you could technically say southwest even to make it way more exact. But anyway, that is all for this year's exam review. Go ahead and review your schedule here at the end. Make sure that you know when you are taking your exams and that you are fully prepared for them. I hope these videos have helped, and I hope that you make the grade that you have worked for on this exam.